The objective of this course that received the name that Learn Math from Zero is the principal goal is that you start to refresh the knowledge about the basic mathematics that will be used as a tool in order to apply to another part of the science, including physics and chemistry. For that, if you feel that this course is interesting for you, please subscribe, give me a like. You can also share it with the other partner and give me a commentary about the topics that you need complete in order to establish a good relationship between the mathematics and the chemistry and physics course. The first part of this course, I think that is very interesting, the natural numbers. In this first part about the natural numbers, the students will be able to complete all of these subjects. For example, read and write numbers using the decimal numbering, use inequality symbols, round natural numbers, perform operations respecting the hierarchy, calculate powers and know their properties, and calculate square roots by triad. These all subjects, these all objectives are very interesting in order to establish a basic knowledge about what are the natural numbers and what are the different operations or other property that should complete the natural numbers, okay? Including the powers and the square root in this case. As a first aspect, knowing the natural numbers, we have or we should to explain or comment what about the decimal number system. The decimal number system allows you to write any number with 10 symbols. Look that we give the name of symbols because 10 symbols are also known for us like feature or digit. In a number, the value of each feature depends on the position it occupies. For example, the units, the tenth, the hundredths, the unit of a thousand or thousand, and tenth or thousand. In the left, in the right chart, you can see that for this number, if you distribute according to the position, you see that this number has 3 units, but had 0 tenths, 700, 5 units of thousand, and 10 and 7 tenths of thousand. That is the form in which you can establish what are the different positions that are present in this type of number. Okay? Another aspect is how you read and write a natural number. First, the features are separate 3 by 3 starting on the right, as you can see to the right. The number should be separate 3 by 3 starting on the right. Okay? Then they are read from left to right. Read from left to right. Is they were 3 digits number. The word thousand, millions, trillion are added where applicable. And remember that the number 30 is always written with a single word. But what about with the number, the lecture, the reading of this number? This number can be read as 9 billions, 30,000, 98 millions, 99,421. Look how, when you read from the left to the right, you have the position, the name of the position in each feature in this number. Also, it's very important the order in the natural numbers. We need to remind that when you have two numbers, one is higher than the other. For that, when the first number is less than the second number, you write this symbol. If the two numbers are equals, you know very well what is the symbol of equals. And if the first number is greater than the second number, you write this other symbol. For that, as a summary, you can write the relationship between the order of the number in this way. For example, 7 is less than 13, or 13 is greater than 7, okay? Or 7 is equal 7. That is the correct way that you can use in order to read the order in the natural number and take present what are the symbology that represent the less than, the equal as, or the greater than. How you can round a natural number? That is another important aspect. It is the substitution for a certain place for all the features by 0. You should substitute the different features by 0. But if the first feature that is substituted is 5 or greater than 5, okay, is increased by 1. The feature appears to the 1 replaced. Let's say an example. If we have this number and we would like to round in the unit of millions. That is very important because you should be clear what is the position in which you like round the number. If you want to write the position in the position of unit of millions, you should take clear that the million is represented by the number 1. That is the position of 1 million. The next feature is 4, but 4 is less than 5. For that, the round number should be this one. That to say, like 4 is less than 5, the number receives 0 in all of these features. And the number 1 is the same. The number 1, the position of unit of million, do not change in this case. But let's see another situation. If you want round to the thousand position, the unit of thousand. In the number, the unit of thousand is 9. Okay, is 9. And the next number is A, but A is greater than 5. For that, the number, the unit of thousand, increase in 1 unit. For that, the result is that you have that in the position 5, as you have 9, and after 9 you have 8, then the 5 change by 6, and all the other features are represented by 0. That is all of these aspects needed training, need that you complete different exercise that you can find in internet or you can find in many of the mathematical books that are present around our life. As a second aspect in the treatment of the natural numbers, we have the operation. We have different type of operation. For example, the sum. The sum means that the numbers that are added together are called summands. Okay, and you can see the definition in the right chart. The summand of natural number have the following properties. Have the properties of commutative and associative. The commutative is the alteration of the order of the summand, does not alter the sum. For example, you can add a plus b, and that is should be equal to the addition of b plus a. That is commutative. You commute, you change the order of the summand, and always you can get the same sum. In the associative property, they can be associated from any mode the summand without altering the sum. For example, if you have, in this case, that the addition a plus b plus c, this should be equal to the addition if you concentrate ab, added a plus b, and after these results add c. Or, of course, you can concentrate the other part, b plus c, and the results should add to a. That is the associative property. You can associate two or more numbers, and the results could be added to the other numbers. Other of the operation is the subtraction. The subtraction, the difference aspect that intervene in the subtraction are naming as minuend, subtracting, and difference. And this is the general sketch in this case. That is a simple operation that you well know from the middle school, from the elementary school, but are extremely important in the application of the basic mathematics to the physics or chemistry. The another operation is the multiplication. And when you multiply a number greater than 1 by another number, okay, is the sum of summand equals to the number b. It is expressed like, for example, a cross b. You can express the multiplication like this, or also you can express the multiplication like this, where the dots means multiplication. The dots is also the same that the cross. What about the properties about the multiplication, where each of the number are named as a factor and the results is a product? In this case, also the commutative property is present. That to say, the order of the product will not alter the results. For that, you can establish that A times B should be equals to B times A. Also, the associative relationship is present. You can associate A times B, and the results should be multiplied by the other number, by C. Or associate B times C, and the results apply to the multiplication with A. That to say that in some cases the parentheses also express multiplication. For example, in this case, we can see A parenthesis B dot C. That means that you give the results of the multiplication B times C, and after the result can be multiplied by A. Also, in this case, the parentheses have the function of the product. Finally, the division is when you divide one number to another number. And the division is the opposite operation to the multiplication. Okay? And it's expressed in this way, where A divided B is C. That means that A is equal B times C. Why? Because if you use this nomenclature, okay, and you say that A divided B is equal C, this B is dividing in the left part, but this dividing can pass to the right part multiplying. For that, we can write in this case that A is equal B times C. Okay? There is other aspect that is important. The division could be exact or not exact. If you have the division is exact, you are in this place. That is to say 18 divided by 6 have a quotient of 3, a divisor 6, and dividend 18. But also, the division could be not exact, like, for example, in this other chart. If you want to divide 45 divided by A, this division is not exact. Why? Because you get a rest. Okay? In this case, the dividend is 45, the divisor is 8, and the quotient is 5. But you have a rest. Okay? You have a rest in the final division. In this case, you can see that, for example, 45 divide 8, that is equal 5. 5 times 8 is 40, but the rest here is 5. For that, this is the rest in this not exact division. The hierarchy of the operation is extremely important. There is a great problem in many students, not in elementary school, not in middle school, not in high school, inclusively at the university level. Sometimes the students are not well prepared in order to follow the order to perform an operation. For that exists an hierarchy in the operation. What are these steps? First, you need to get the operation between parentheses. That is the first. Okay, for that, if we have A plus B times C, the first operation is the operation that you can see in parentheses. After the multiplication and divisions. And finally, the additions or subtractions. That is the order. For that, always you should pay attention if you have parentheses in your equations and solve the parentheses before and after, multiply or divide. Finally, you can add or subtract. If there are only multiplication and divisions, okay, or there are only addition and subtraction, are performed from left to right. From left to right, always. For that, other properties is that when you have the addition or are present the 0, okay, the 0 is a neutral element in the addition. Like the number 1 is a neutral element in the multiplication. If you have 1 times A, there is A. Okay? But the distributive property is also important. If you have A multiplied by b plus c. Okay? You should effect the multiplication between a and b. For that, this is a times b plus a times c. A times c. That is different way in order to apply the different property in this case. A final and very important and well-known important property is that when you multiply any number by 0, the final result is 0. What about with the power? Another interesting aspect in the application of the basic mathematics to the solution of different problems in chemistry and physics. We know that the base powers and the natural exponent. What means that? A power is a shorthand way to expressing a multiplication of equal factors. For example, 2 raised to 4 is a power. And means that you should multiply the base 2 4 times. For that, the base 2 is multiplied 4 times, or for the time that you have represent in the exponent. Okay? For that, you have in this example that if you have 24 raised to 9, you should multiply 24 9 times. Okay? But what about this multiplication? It's 25 times 25, and the results times 24, and the results times 24, and the results times 24, and so on. For that, this is the answer when you have the 24 numbers raised to 9 as an exponent. Okay? Notice that the simplest powers are those that they are based on 1 or 10. If you have a base of 1 or you have a base of 10. This is this other information. If you have 1 raised to 5, that means that you need multiply 1 5 times, and the result is 1. But also, if you have 1 raised to 10, 1 raised to 10, okay? In this case, you should multiply the number 1 10 times, and also the result is 1. But what happened is you have the base 10. The base 10 raised to 3 means that you should multiply the base 3 times. And this is another result. The same for 10 raised to 5. You should multiply 5 times the base 10. And an important aspect is that you don't confuse 2 to 4 and 2 times 4. 2 to 4 have different results to 2 times 4. 2 raised 4 is 16. 2 times 4 is 8. Okay? According to the powers, what are the principal properties? For example, if you have this product, you can write the same base and the addition of the exponent. If you have a quotient, that is, for example, a raised to n divide 8 raised to n, okay? That is the same to say a raised to n times a to minus m. Okay, for that, this is a, the same base, and the subtraction of the exponent. That is in the case of the quotient with base, with the same base. In the product with the same base, you added the exponent. In the quotient with the difference, with different exponent but the same base, you put the same base and subtract the exponent. If you have the power of power, you write this one. If the product and the same exponent, you can write the product into parentheses raised to the same exponent, or the quotient and the same exponent. Okay, also these two properties are very similar. Another important aspect is that some students have not taken present that when you have a number rise to 0, the result always is 1, independent what is the number, what is the base. But if you have a base rise 1, then the value is the property A. All of these properties are represented in numerical way in these examples. Also, one important aspect is the square root. You can find that the square root could be exact or not. The example of an exact square root is this one, okay? And you can see that the square root is the opposite operation to write the square. For example, if you have the root square of 64 is equal a, okay? But you can pass from this square root to square. That to say pass to this one. Why? Because if you introduce in a square exponent both sides, you can cancel the square with the square root, and you get that the square 8 is equal 64. For that, you can pass from this notation with a square root to the notation to square. For that, they say that the square root is the opposite operation to write squared. That symbol is known as a radical, okay? And the number within the radical is the radicand. For that, if you have that the symbol is the radical, and the number that you have into the signal, the sign, is the radicand. Okay? Now, the students are not able to give the solution or write the solution of a square root. Why? Because we have the advanced technology of the calculator. What is the whole square root? Remember that we have an exact square root, but also we can find not exact, okay, square root. For example, the whole square root is, in this case, this one. For example, when you have the square root of 70 is equal 8. In the same way, you can pass to a square. If you introduce the left part into a square and the right part into a square, you cancel the square with the square root, and you get that 70 is equal, okay, to this one. But in this case, a to square is not, okay, is not 70. For that, this result is not an exact square root. You, in this case, like the division, you have a rest. And this rest is represented by this feature in this case. For that, there, you have that the a to square is 64. For that, how many you need to get 70? You need 6. For that, in this case, the rest is 6. And in this way, 70 minus 64 is 6. For that, the rest is 6. For that, you need to add this 6 to 64 in order to get the real number of this square root. Okay? The square roots should be solved using a trial. The square root that are not exact, you should use a trial in order to finally get the result that you are perceiving. With this short information, with this basic information, I would like to say that if you find interesting this first video, because we will continue more videos than this one, you can please subscribe, give me a like. If you feel good, share with other students, and also leave your comment down the video in order that if you need another type of explanation, or if you need that I commented another topics in relation with the mathematics in order to establish a basic knowledge, in order to apply this basic knowledge to the chemistry or physics science, that would be very nice for us. For that, I would like to thank to you in order to hear this short but instructive video, and I hope to see you very soon. Remember that if you subscribe when we upload another videos, YouTube, okay, contact you with the information that a new video has been uploaded to the channel. Thanks a lot.